there was a way to ease the stresses riders feel and amplify the fun instead. Especially with advanced features like this, if it feels unnatural to the rider, it's basically unusable. That's why our work focused on eliminating such factors as much as possible. To give riders more comfort and peace of mind, Yamaha developed a next-generation electronics suite featuring adaptive cruise control and millimeter wave radar-linked unified braking. The electronics and millimeter wave radar are an integrated whole, providing cohesive control of the adaptive cruise system, brakes, suspension and throttle. This feature for rider comfort can control braking and acceleration automatically with a natural feel in various situations on the road. The system consists of the millimeter wave radar, an IMU, various sensors, the adaptive cruise control feature, the unified brake system, and the suspension control unit, with the sensors and computers communicating via CAN bus, much like how the brain sends and receives signals from the senses. The damping velocity of the CAD's semi-active suspension is optimized via the SCU, and the quick shifter now allows for clutchless upshifts and downshifts whether adaptive cruise is on or off. Also, the rear brake disc was enlarged to provide a natural feel under braking, as well as to accommodate more frequent application by the adaptive cruise system. Imagine going for a full-day tour. It's early in the morning and time to get going. A fun-packed day of roads awaits, and the rider is fully charged and ready to go. However, to get to the fun, there are first city streets, highways and other roadways to navigate, and riders are often left at the whim of traffic conditions. But the Tracer 9 GT Plus's features help minimize such burdens, making the journey more comfortable and more enjoyable. When the rider sets a speed and following distance for the vehicle ahead, the millimeter wave radar-linked adaptive cruise control responds to the acceleration or deceleration of the vehicle as the bike follows behind. The vehicle ahead slows down. The bike automatically applies front and rear brake pressure to decelerate and maintain the set following distance. If braking or other rider intervention becomes needed, an alert flashes on the main display. Another vehicle suddenly cuts in. The bike slows down to maintain the set following distance and makes the vehicle that cut in the new target to follow. The vehicle in front leaves the lane and the road ahead opens up. The bike automatically accelerates to the set speed, with the engine response made to feel natural, not too sudden and not too sluggish. If the rider wants faster acceleration when returning to the set speed, they can downshift with the quick shifter, even with the throttle open, to get up to speed quicker or even go faster if desired. Another vehicle suddenly enters the lane. Adaptive cruise disengages when the rider applies the brakes, but the millimeter wave radar continues to detect oncoming obstacles. The unified brake system provides assistive front and rear brake pressure for additional stopping power. In general, inertia causes the front fork to compress when braking, causing the rider to pitch forward. However, Yamaha's system aids in braking while adjusting front fork compression velocity at the same time, helping dull this unnerving feeling for the rider. The Tracer 9 GT Plus's electronically controlled suspension is normally supple for comfort, but aptly firms up under hard braking. How was Yamaha able to develop this sophisticated system? The chief development goal was to deliver operation and response that feels natural to human senses. It is the result of a close collaboration between the system engineers and test riders. In tuning it for human senses, what we perceive during acceleration and braking is both acceleration and the rate of change of acceleration over time. So we developed a system taking these into account when riding and worked with the test riders to tune and finalize it. Since its founding, Yamaha has pursued ways to reduce rider stress in how each machine responds when riding, cornering and braking. This new system is another page added to that history. Development begins by listing situations a rider is likely to encounter and then identifying the requirements for handling them. Based on that, we then build algorithms for the electronics and spend a significant amount of time creating the control program. At the same time, we start selecting the hardware needed for ideal performance. Once the program has been debugged, we run it through a test setup and check that each component is functioning properly. After that, we install the program on the test bike's ECU, Unified Brake System and CAD suspension, and finally begin real testing. The Tracer 9 GT Plus was trialled on Yamaha's test course and on public roads. The bike was tested on highways, local roads, twisties and more over several hundred hours and several thousand kilometers. On public roads, the unexpected can strike at any time. That's why we accounted not only for other vehicles on the road, but also factors like rain, wind, fog, and even the rider's state of mind while on the bike. Our goal was to allow the rider to put 100% of their energy into enjoying the Tracer 9 GT Plus. The comfort and peace of mind that this new electronics package affords enhances the joy of motorcycling and helps satisfy the desires of riders who want the next level of sophistication. The seductive exhilaration felt when users truly become one with their machine is our shared baseline when we quantify and integrate it into a Yamaha's performance, and is the definition of our Jinki Kanno development ideal.